want to welcome you to the Google Executive Talk on Open Innovation Ecosystems. And super excited to talk about how do we bring open innovation more so to hardware and systems, as Open Compute always has been working on doing. My name's Amber Huffman. I'm a principal engineer at Google. Prior to joining Google last November to lead our data center ecosystem engagement, I was at Intel for 25 years leading a lot of ecosystem work such as NVM Express. So I'm excited to talk to you. So the first part of the talk is going to talk about open innovation ecosystems and just what's the power of open innovation ecosystems, and talk a little bit about what did we see the velocity from open source software. Then I want to talk about systems and hardware evolution, and if we take those learnings about open innovation ecosystems, how can we then apply those to hardware and systems, and how is it uniquely different in systems and hardware that we have to think through to really drive with that same velocity. And then I want to finish up with just recapping those principles and inviting some other Googlers to the stage that are leaders at OCP that you may want to ask a few questions to. So the key thing about open innovation ecosystems is velocity. There's nothing that we as a community can't do faster together if we're clear and moving forward on common purpose. So this is obviously a lot of icons, but Google is infused at its core with open source software. So if we look at Gmail, look at Chrome, look at Maps, it's all based on, the Google infrastructure is based on open source software. And so we truly believe in our DNA that open together is better. So if I look at the last 20 years of open source leadership in software, this is the kind of picture that I want to build out in 10 years or 20 years as we look at open source hardware and systems and where we are going together as an open compute community. So if we go back to the beginning, when Google was a startup, we started contributing with Python into Linux because we needed to utilize Linux infrastructure to build our business. And so as we started to work with Linux and realize the power of open source software and the benefits, we just started contributing more and more. And that goes to whether you're looking at Kubernetes, or you're looking at something like TensorFlow, or all these great things with Android and Chrome. So it's a virtuous cycle that continues to build and build and build. And that builds out to just this incredible portfolio that Google's had the opportunity to contribute to, but we as the ecosystem, there's so many of you in this room from all sorts of companies that I'm sure has that same similar graph on open source software. So how do we build this and just bring that community and that leadership and that innovation together? If we look at big data just as one example, the Google file system, MapReduce, and Bigtable, if we look at those papers that Google published, those inspired things like Hadoop and Hive and Spark. And so how do we just have that innovative cycle of the great ideas that each of us brings to that open source community, and then we build these amazing things together that our world runs on, and we improve everything together. So one thing I found interesting is this is the Cloud Native Computing Foundation, and this is their map of what was the work and the contributions in 2020. And I know you can't read from where you're sitting. But on the upper right, in the big blue one, that's Kubernetes. And that's just the size of the amount of contributions that the ecosystem is bringing to this. And so each of these represents a different project in the Cloud Native Computing Foundation. And what you can see is just all of us coming together to really build the ecosystem. And that velocity is just amazing of what we've been able to do, and the way we've been able to pivot on things like the pandemic to really bring the value to the world. So that's all very exciting and motherhood and apple pie, but let's talk about systems and hardware evolution and some of the challenges that we've seen of how do we do open source hardware? How do we do system co-design? And just like with what Partha talked about in his keynote this morning, how do we unlock the open innovation ecosystem, and what are some lessons that we've learned already? So a first challenge I wanted to throw out to everybody is the challenge of clear customer direction. I just chose 4 customers, hyperscalers, for this anecdote of a graph. But what you can see on this compass of if you have major customers pulling in completely different directions, things are very painful. If we look at the hardware investment that's required or the systems investment, it's very significant. And so we really need customer alignment, because otherwise each company, especially if you're doing silicon, is stuck in this loop of, but they want this and they want that, and both of them are important, and what do I do? And so it's incumbent upon us of how do we come together? So one example of how do we bring clear customer direction together I wanted to point out is Calyptra. So what we had a few years ago is, if you recall, it was kind of in the middle of this picture on the left. You have this, you had various different proposals from many companies that were all many of them are great proposals, but if we're not aligned on something, it becomes just almost a food fight, right? And it's not moving the industry forward. So how do we come together early enough and set a direction and have common purpose by multiple customers and really bring the ecosystem together? So that's really where Calyptra has gone, is you had Google and Microsoft getting together along with AMD and saying, hey, this integrated root of trust, how do we up the playing field on confidential compute, really get to attestation at a package and a SoC level? And then also, as we look at the challenges of how our world is changing, right, with edge computing and now physical interposers happening at the edge, it's much harder to physically secure systems. And so that's where we really need to get that integrated root of trust, the common vision of what do we go and do together. And that's really brought us together with Calyptra, that we're super excited for the 0.5 spec that all of you can download now, the code that will be delivered soon in Chips Alliance. And we can then, with this virtuous cycle of AMD, NVIDIA, Google, Microsoft, and I'm so excited to see so many other companies' names behind this as we move forward, because this vision is not just about SoCs. I mean, it's many SoCs, GPUs, SSDs, CPUs. How do we come together and really infuse this in everything we have? So really come together and get that clear customer direction, because then we can move fast. The next one I wanted to hit on of a challenge that I see in the hardware and systems ecosystem that's difficult is clear metrics. So say we can get customers and all of us together, if we're not clear on why we're getting together and what success looks like, we're going to have a really hard time getting together and coming to an overall solution. So the next thing is about getting clear metrics. And the one I wanted to touch on here is about the new server component resilience workstream that was touched on by both Intel and Google this morning in their presentations. So as you've seen in the paper, Cores That Don't Count from Google, and the paper from Meta, it's been identified that silent data corruption, it's actually always been there, but now that it's at scale and at the lithographies we're at, we have to take more action. We can really understand, and how do we take more mitigations and understand this as a community together? The first thing in the new work stream that Google, Meta, Microsoft, Intel, AMD, ARM, and NVIDIA are doing is figure out metrics. That's the first thing. Actually, some of the discussion is literally about how do I define what silent data corruption truly is? If it's buggy software, is that a silent data corruption? If the OS crashes, it's not silent because the OS crashed, but do you still count that? So how do we get clear about what the metrics are? How do we make sure it applies to accelerators as we're getting to increasingly custom silicon, right, to accelerate different workloads? How do we make it general enough that it can apply to whether it's a CPU, a GPU, an SSD, a accelerator, but make sure that it works well? So that's the next thing we have to do, is really work on that metrics, and that's where we're starting from ground zero in this work stream on server component resilience of define the metrics. Then we can also, in parallel a bit, but access to faulty machines and test content and all of those great things, but really talk the same language is so critical in how we move forward together and really aim for the common goal that we're after. The last one I wanted to talk about in hardware that I think is a unique challenge, I mean, I know that in software good development, we have modularity, but especially in hardware, I mean, think of how quickly we could have built Mount Rushmore out of Legos, but so how do we look at modular building blocks so we can all work together to decompose things and really work together to pull the total solution together? The one I wanted to highlight here is modular hardware systems. So the DC MHS vision of coming together and saying, hey, in the previous model where we have a CPU and a motherboard and a platform and a this and a that, and how do we do the mixing and the matching, it was becoming extremely difficult with form factors and other pieces. And so the innovation of looking at the host processor module and really getting that commonality so that you could have these mix and matches has been critical. So as Intel highlighted in their keynote today, really pulling together this set of companies between Dell, Google, HP, Intel, Meta, Microsoft, to really deliver the 1.0 of the DCMHS spec has been very valuable, and it's just building into revision 2 where we have more collaborators coming on board. And just how do we create that modularity so we can all deliver what we're best at and have this mix and match and be adaptive? Because if anything any of us have learned over these past few years is things are change quickly, and how do we adapt? So this is another great example for how we move forward together. So in driving open innovation together at Google, we believe in open ecosystems, and open innovation is really how we have the breakthroughs. And so as you guys saw this morning in Partha's keynote, we're at a really pivotal moment of where, with Moore's law slowing, we're going to have to reimagine how we are doing the server design, how we do custom silicon, how we do data center design, how we do all of these things sustainably. And so if we lean in together and we follow principles of get clear customer direction, have the clear metrics, modularity, and really work together, we get that virtuous cycle of the ecosystem pulling together. So at this point, I think you want to potentially, hopefully, have a little Q&A with a few of the Googlers that are very active in Open Compute. Over the past few years, we've gotten much more active as Google at Open Compute as we see the value of this being the one place that the system comes together. We have Partha, who is our OCP board member and also a fellow at Google to join us. We have Priya. She is our sustainability lead that's been very involved in the data center facilities sub-project for sustainability and is an active leader in the sustainability work that you guys heard about it as a fifth tenant. Madhu, who is the data center facilities lead. As I call you guys out, you can come on up. So we have Madhu, who is the data center facilities project lead. Dan Frame has been leading a lot of great diagnostics work and in the test and validation team. CMAC, I think needs no introduction, leading the biggest, being the incubation chair or incubation committee for server, which is OCP's largest project. And then Andres, who you heard a lot about Calyptra this morning, and also multi-brain data server, and Andres is a leader in both of those. So does anybody have any magical questions or unmagical questions? Partha will ask questions if you guys don't. I think they're recording, so if you...
Mark Hill, Microsoft. Can you say anything about your sustainability efforts?
Thanks for putting me on the spot.
Is it on? There you go.
Thanks for that question. So from a sustainability standpoint, we all know about the scope 1, 2, and 3. I think we've all got a good handle on scope 2, how we procure our energy. Scope 1, there are solutions out there. We just have to get it to the right place where we can deploy it and get the infrastructure ready for us to deploy. But our biggest issue is scope 3, and I don't think we have a handle on that. That is something that we all need to pool our resources. And as Amber mentioned, we need to set the direction. So looking for collaboration in scope 3, and I think we all need to work together to get there.
I think you're saying start with metrics is the place you guys are starting, right?
Exactly.
And just to add to Priya's answer, I think water usage is also going to be something pretty important. We spend a lot of time thinking about scope 1, scope 2, scope 3 emissions, but thinking about data center water is also going to be pretty important.
Don't be shy or they'll ask me questions. So I'll ask a question. Andres, what do you see as with Calyptra? Where is Calyptra going? Give us a little more than what we saw in the teaser in Partha's keynote.
Take over the world. Now, what do we put Calyptra together, right? And the main reason why we put it together is if you look at the security world, and this is the kind of what we identify coming into OCP and what made us very excited to join OCP and work here, it can get really fragmented with a number of solutions that don't quite make sense. And that really hurts us from an obvious perspective. You know, respect the user, one of our key values. Like, we really want to take care of people's data. We want to uphold that confidentiality. But it also hurts us because it makes it harder to push products out, right? And to be competitive. So what we're trying to do here is, the key value here is transparency and consistency. Try to find a common approach that satisfies the data center journey of knowing exactly what you booted, being able to cryptographically attest and make statements about the code that you booted being the code that you intended to boot, and to put that in SoCs, traditional CPUs, GPUs, NICs. Like, you see our partners, you realize the scope and the reach of what we're trying to do here, both in first-party and third-party products. Yeah.
Thanks, Andres.
Question for Dan. Regarding test and validation, what are challenges you're facing today, and what's your strategy to handle those?
Yeah, I think the biggest thing that we're trying to do right now is basically, you know, Google doesn't want to design everything anymore. And open hardware is fantastic, but, you know, we can't productionize open hardware unless we can bring it into our data centers, right? So this is making sure that we have the diagnostics, we have the test, we have the benchmarks, we have the qualification, and everything that we can do to make sure that the hardware works in our environment, right? That would be one of the challenges that we're trying to work with our OCP members with. The other would be some of the areas that we've touched on. Amber touched on SDC earlier, right? You know, where we're trying to figure out, like, how long do we wait for something not to happen when we're doing SDC testing? These are some of the challenges that I would say that we're focusing head on and we're doing with our partners at the OCP rather than going it alone.
My question's for Andreas again, a follow-up to where you were at a second ago. With the new specification that we're looking at, what does that mean for the other fragmented pieces we've looked at with, like, Cerberus and Titan and various other things? Is this a consolidation of those things, or will those things still be applicable in certain instances, or is this to replace those things?
Well, thank you for the question. So the first thing that I would like to say, we do have a 45-minute session on Thursday, right, for Calyptra. So let's just keep it to 2 or 3 questions, and this is a Q&A with a lot of people. So the second thing, different pieces of the system have different roles. If you look at the OCP 1 year ago, we talked about composable system architectures and separating the role of platform availability, which is, you know, managing your firmware updates, doing recovery, etc., and secure, attested, measure boot. So Calyptra is a second, right? And it's meant to bring commonality, strength, not a low bar, a high bar, to that space. We still keep the chips that we manufacture and trust for the availability side of the house. So we continue to use our Titans. I will let Microsoft speak to what they do. I mean, they have a presentation on something called Hydra. You know, they'll talk about it, right? It's their stuff. Those serve a different and complementary role, right? When you're a cloud provider, you need to take care of people's data, but you also need to be up all the time with millions of machines against a lot of adversaries. So these two things are complementary. I think there's a lot of people here, so we have a session on Thursday about Calyptra for further questions.
How do we ensure that, or like how do we ask companies to open source and not keep everything like proprietary? So that aspect, and then who owns the compliance to NIST and FIPS for like open hardware? So those aspects, and then how are we contributing to some of the like communist countries to also participate in the open source projects? Like we don't see so much coming out of, like, example, China.
So some pretty big questions you ask. Who wants to take that one?
I mean, I can start on open source hardware. I think that the value of open source ecosystems and open ecosystems is that, and the incentive is, I don't think Google would be what it is today if it was not built on open source software, right? There is a virtuous cycle, so it is a win-win for both the company contributing, that they're getting value from the benefit outside their walls. So I think that one of the key things is there's no single company has all the smartest people and all the innovators in a particular spot. So if we can find collaborators and really enable us to collaborate with each other and build together, I think that that's what incentivizes people, and that's why, you know, Google is, I think you guys can all see over the past few years, has taken a much stronger position in OCP because we see the value in extending from software towards systems, and OCP is a place to do that. So it's just a virtuous thing and a selfish thing, honestly, for companies to have access to great innovation in this community. CMAC, you want to add?
Yes, as we are here as part of the OCP community, you guys know that the summit is a place for engineers to talk to engineers. That's the first thing that we normally try to do. We have our own companies, we have our own businesses, but when we talk to each other is when we can talk about use cases of interest of the future, and that we work together and solve them. As an example, last year we were talking about modular hardware, and this year you do see that modular hardware system as a specification is out there. And how was it created? It came from the fact that a number of people got together, different companies got together, worked together, defined a specific use case, and as Amber said earlier, as we define the metrics and define the use cases, then good people get together and solve the problems. This year, for example, you do see a lot of excitement around CXL. So I'm going to say that, hey, this year we're going to talk about the type of things that can be done. We haven't done them yet, and we're going to extend the offer and invitation to the community to get together, solve some of these problems, and hopefully in Prague as part of the regional summit, and then later in maybe next year about the same time as Global Summit, we will have some results.
And just to answer the last question about how do we, I'll answer the spirit of the question, which is how do we think about other geographies as well. Just wearing my OCP hat, we had a really excellent OCP China Day a few months back, and so we do have a strong presence from some of the hyperscalers who are in that neck of the woods. We also have, as CMAC mentioned, we have a Prague OCP Summit as well, so we do have a European presence as well. So this is by no means just limited to a particular geography, so we do try to be inclusive there.
One other comment, since OCP has great presence in China as well. The China Day and at OCP draws over 200 million people dialing in. I know that I was excited about that last year when I heard it.
And nothing crashes. It's good.
I was just curious if you could comment about what kind of technology is that coming that you feel is leading the way in hardware efficiency and sustainability, things like 48-volt or cooling innovations. Just if you could comment on your priorities there.
Yeah, I think OCP is pretty active in liquid cooling, which obviously looks to push the performance of chips and systems, but is also an efficiency play and related to sustainability. So I think you'll find a lot of demos in the expo and talks around liquid cooling and immersion cooling. So that would be one area, I would say.
Well, with 1 minute left, Partha, would you like to say any closing comments?
I want to thank everyone for coming. So I think, again, both coming to the broader summit, wearing my OCP board member hat, but also wearing my Google hat. It's a pleasure to see so many people here. Again, I would like to just reiterate the message that I mentioned at the summit. There is, to answer the last question, there is tons and tons of opportunities ahead. And cooling is one of them. Sustainability is other. We are rethinking server design. The hardware-software co-design aspect, which kept coming in every single keynote today, is very interesting. OCP is also evolving in various different ways. We are starting new work streams. we are honestly starting new business models as well. You saw the presentation with Linux Foundation, where OCP is trying out new kinds of partnerships so that it's not just a very narrow view of hardware. We are starting to look at a systems view. Same thing with the resilience work stream. We are taking a full system, full solution view as well. So it's a time of a lot of opportunity and a lot of change. So I think there is tremendous things that we could do if we all work together. So looking forward to more community collaborations as well. And I will leave with one request, not necessarily at this meeting, but if you have suggestions for what we could be doing at Google, both in terms of enabling the community or in terms of moving OCP forward, reach out to any one of us, and we'd be happy to take that feedback as well. So thank you very much.
Thanks, everybody.